Hello. We are going to be learning about intermittent IV infusions. Okay. This is in week, apologies. This is in week 7 for Math 203, and this was the last thing we learned. So this is intermittent IV infusions, also called secondary or piggybacks. So here are the steps. So sometimes IV medications are delivered on an intermittent basis. If it's not already prepared, you first have to calculate the amount to administer, which is how much medicine they will need. So the first step is calculate the amount to administer, and that's a dosage problem for me, D over H times Q. And then you add it to the milliliters you're given. You're then going to calculate the flow rate for that liquid over an amount of time. Milliliter in time may be less than usual. If in minutes, you'll have to convert to hours because you're using the pump. So it's taking everything we did learn this week and putting it all together. So this is what we learned last week, earlier in the week. So this is our different infusion pumps. So this was the primary infusion. So earlier this week when we learned milliliter per hour, when they gave us minutes or they gave us hours, we would have to calculate the flow rate for this infusion pump, and that was in milliliters per hour. Here, this is where you're going to have a certain amount of liquid in the primary bag, and this secondary bag is going to be the dosage problem. So this is going to be the medication that needs to be administered, and it will be included to your primary bag. And notice that both of them go through the same infusion pump. So you have to add these two together. Okay, so let's go to the next. So here's an example. I'm going to turn my highlighter on. So we are looking for best advice. You want to jump straight to the question. And the question here is calculate the flow rate. Sorry, I meant to use my highlighter. Now it's in the wrong color. I actually will stop using the highlighter after this one. Calculate the IV flow rate. So that's your goal, and that's going to be for your pump. So up here it says ordered, you have your Loxodin 75 milligrams with 250 milliliters, D5W, piggyback over 90 minutes. What you have on hand, and this is a key right here, this is what you have on hand lets you know that you have medication you need to administer first. So what's on hand is that aloxidin 5 milligrams per milliliter in the 100 milligram vial. Irrelevant. So let me go back to my pen. So uh, here, injection 70 milligrams single use vial. Irrelevant. Reconstituted with all this, it doesn't matter because all this is a dosage problem. What's ordered over what's on hand times the quantity, because the first step is calculate the amount of L'Occitane to administer. So this is going to be the medication. So the medication he's ordered is 75 milligrams. What's on hand is 5 milligrams per 1 milliliter. So 75, sorry. Okay. So sorry, 75 divided by 5 will give you 15 milliliters for his medicine. So now you're going to go to the next slide to complete it. So we know that his medication is going to be 15 milliliters, and it does tell the steps down here. But so step 2 is you're going to calculate the flow rate based on the primary bag of 250 milliliters. So this primary bag has 250 milliliters, and this piggyback is going to be the medication. Okay, so this piggyback holds, or this little piggyback bag holds 15 milliliters. Now, see again, they're both going through the infusion pump. Actually, this is a person, there should be a pump right here. So you need to add these two numbers together to calculate how many milliliters they're getting, and then you'll find how much per hour. So when you add the two, 250 plus 15, and it says right there, it gives you 265 milliliters. And again, it was over 90 minutes. So you have one of two options. You could do 265 milliliters um, over, sorry, 75 milliliters over, apologies, either 90 minutes. And then since it's in minutes, you have to convert it to hours. So 60 minutes is 1 hour. The other option is if you know that 90 minutes is an hour and a half, you could have done 265 milliliters over 1.5 hours. Either way, you should get the answer of 176.6. And as a policy, we're going to round to a whole number for our pump, and you'll get 170, whoops, sorry, 177 milliliters per hour. 177 milliliters per hour. Okay, so I got a couple more. So this one it says in intermittent practice. So what is ordered is you have the medication. What's ordered is 125 milligrams, and that's going to be put into 250 milliliters. Over the 120 minutes, since I'm doing flow rate, I'm going to use liquid and time. And then you have your tubing calibrated to the 15 GTTs per milliliter. Okay, so let's jump to the questions. Calculate the flow rate for the infusion pump. Now, an infusion pump is milliliters per hour, which actually makes that GTT per milliliter irrelevant. The only time you need that 15 GTT per milliliter is if you're looking for drops per minute. But we're looking for the infusion pump, which is milliliter per hour. Notice that they don't give you, you can see they don't have anything that's available. They don't have anything that's on hand. They tell you what the doctor ordered, but they don't give you the H and the Q. So that means that this is also irrelevant. So now all you have is 250 milliliters over the 120 minutes times 60 minutes over 1 hour. Or you could have done it over 250 milliliters over 2 hours because 120 minutes is 2 hours. Either way, 250 divided by 2 should be 125 milliliters per hour. Okay. Next question. Sorry, I'm a little squeaky lately. So jump to the question, calculate the manual flow rate with this drop factor. So you're looking for GTT per minute because it wants the manual flow rate. So he's hospitalized. The physician orders 250 milligrams in that 50 milliliters over 65 minutes. So this is his medicine. This is the IV primary bag. This is the time. So the hospital pharmacy has prepared a 50 milliliter bag, which is that one, with a concentration of 5 milligrams per milliliter. So it says the pharmacy has prepared. What that means is everything else is irrelevant. That means you do not have to do the dosage problem because they already put that medication in that bag. So now you're just going to calculate the manual flow rate, which is in drops per minute. And I just use the formula milliliter times the drop factor over all the minutes. Okay. And I got 15.3, and GTT per minute is always a whole number. And again, at the bottom, it does say since it's already prepared. Last one. This is a new slide for anybody when I printed them out. Well, actually, this is a new slide. I just wanted to give some extra practice. So, jump to the question. I want the flow rate for the infusion pump, round to the tenths. So, for the infusion pump, I'm looking for milliliters per hour. So, a client with all of this. The order for the order calls for the medicine 0.7 grams. That's in the 100 milliliters over 12 hours. The nurse prepares a dose of whatever, using a vial that's labeled 250 milligrams per 5 milliliters. Calculate the flow rate. So, since they gave you the medicine, it doesn't say that it's already been prepared. You are preparing it now. So first step is to do the little dosage problem. So 0.7 grams over the 250 milligrams per 5 milliliters. Notice the units don't match. So to convert gram to milligram, you'll multiply by the 1,000, which would give you 700 milligrams over 250 milligrams per the 5 milliliters. And that gave me 14 milliliters. Okay. And so this is the medication. What's already in the bag is the 100. So you're going to have to add the two together. So he needs it. There's the 100 is the primary bag. He needs 14 milliliters of medicine. Both of those are going through the pumps. You add them together. So 114 milliliters. And then the last step is to find the milliliter per hour for the infusion pump. So he's getting a total of 114 milliliters. And that's over the 12 hours. So you just divide, and my answer came up to 9.5 milliliters per hour. And it did say to round to the 10th. Since it's already in the tenths, that's going to be your answer. I think I have one more. Yep, last one. Okay, so what's ordered is 350 milligrams. It's to be added. That's the other key word. It's going to be added to the 100 milliliters over 30 minutes. What you have on hand is 500 milligrams per 15 milliliters. And this one does break down those steps. This one does say, and so on connect. It could be multiple steps. Sometimes the first answer is the how many milliliters will you give? Second answer is okay, find the milliliter per hour. So for this, calculate the amount to administer. That's your dosage problem. So 350 milligrams is ordered. There is 500 milligrams on hand times that 15 milliliters. That gives me 10.5 milliliters. You do not round that. This is his medicine. This is not the pump. This is not milliliter an hour. You do not round. Step two, which really isn't listed there, you're going to add the two together. So there's 100 in the primary bag. You're adding 10.5 to that, which gives you 110.5 milliliters. So this is his total liquid over 30 minutes. And you want to find the flow rate for the infusion pump. So you could do 110.5 milliliters over 30 minutes times 60 minutes over 1 hour. Honestly, most people do that. Another option could have been 110.5 milliliters over, 30 minutes is half an hour over 0.5 hours. Either way, your answer should come to 221 milliliter per hour. Okay, hope y'all find that helpful.